Hello guys, this is Prime Concept. Now I'm here to solve this problem. I've solved it in one of my videos, right? So I'll be solving the same problem using another method based on demands from students. So I'll be using method 2 to solve it. So when you come across the other one, you check which of them best suits you, right? Now let's solve this. We have two equal positive point charges, Q1 and Q2. They have values of 2 microcoulomb, are located at x equals 0, y equals 0.3. So remember, Q1 is located at x equals 0, y equals 0.3. So if you locate that, it means if this is our origin, it means that it is at the y-axis, right? So positive y-axis. So this is 0.3. So this is what we have. Now, and this is where we have Q1. And they said this, and then x equals 0 and y equals negative 0.3 respectively. So it means Q2 is located at x equals 0, y equals negative 0.3. So it means that Q2 is along the negative y-axis. So this is 0.3 meters. So this is where we have Q2. Now, we say what are the magnitude and direction of the total or net force that these charges exert on a third charge Q. So the third charge Q at point x equals 0.4 and y equals 0. When y is 0, it means you are along the x-axis. When x is 0, you are along the y-axis. So it means our third charge Q is along the x-axis at a distance of 0.4 meters. So 0.4 away. So 0.4 meters away. So this is where we have our charge Q, right? So the next thing you want to do is to quickly join these charges. So I'm going to join Q1 to Q. I'm going to join Q2 to Q. So I'll quickly join them. Now, from the question, you would notice that Q1, Q2, and Q, they are all positive charges. So watch. Q1 is our source, Q2 is our source, while Q is our test charge, because we're trying to find the force that Q1 and Q2 would exert on Q. So the ones exerting the force are your sources. I've mentioned that over and over in our videos. Now, for this positive and this positive, you're going to have a repulsive force. And remember, repulsive force usually points away from the source. So I'm going to indicate that like this. So this is my F1. Okay, let's call this Q0 so that we can say F10. Now, you check the same thing, your Q2 and your Q0 still are positive charges. So you're going to have repulsive force away from the source. So I'm going to still denote this like this. So this is F20 away from the source. Now, it simply means that these two forces can be resolved to the x and y axis. So I'm going to draw my coordinates. So I would have this. So I can resolve this to this point. I can also resolve it to this point. I can resolve this to this point. I can also resolve to this point. So in order to resolve, we're going to find our angle theta. So if this place is theta, this is also going to be theta. The reason is because this place is 0.3, this length is also 0.3, this is 0.4, so they will have the same value of angle theta. So and this place would also be theta. Why? Vertically opposite angles are equal. This place would also be theta. Same reason, vertically opposite angles are equal. So the next thing I want to do before I proceed with solving the problem is to find the value of sine theta, because I will need it. Now, okay, before sine theta, you need to know the length, right? This length, we can get it based on Pythagoras. So according to Pythagoras, this place, I'm going to call it R. So R is going to be the square root of 0.3 squared plus the square root of this, right? 0.4 squared. So if you solve this, if you punch this with your calculator, you get 0.5 meters. So that is this length R, which is 0.5. This length also is same thing, 0.5, because they have same values. So we've gotten that. The next thing I want to get is, let me rub this part. So the next thing I want to do is to find sine theta. So sine theta from this triangle, sine is opposite over hypotenuse. So opposite is 0.3, my hypo is 0.5, right? Then let me also get cos theta. Cos is adjacent, which is adjacent is 0.4, the hypo is 0.5. So 0.4 by 0.5. So I have my sine, I have my cos, right? The next thing I want to do is to find the force now, F10. F10. F10 is simply going to be KQ1, Q0 divided by R squared. So I have K is 9 times 10 to the power 9. Q1 is 2 times 10 to the power, what is the value? Okay, 2 times 10 to the power minus 6. Then Q0 is 4 times 10 to the power minus 6. All divided by R. This is our distance, 0.5 squared. So if I punch this, I'll get, let me quickly punch. This is 9 times 8. So this is going to give me, so this is going to give us 0.29 Newton approximately. So this is what we have. So the next thing, since Q1 and Q2 has a value, so it means that F20 would also have the same value as 0.29. So this is going to be the value. You don't have to solve it again. They will have same value since they told us that the charges are equal, right? And then F10 is between Q1 and Q0. F20 is between Q2 and Q0. So they would have same values. Since we've gotten this force now, the next thing is we want to resolve them. So I'm going to find their component along the x direction. So along the x direction, which is this is our x direction, I'm going to resolve this to the x direction. And I told you that whenever you are resolving forces, if you are closing an angle, you use cosine. If you are opening the angle, you use sine. So when I'm taking this force to come to the x-axis, what is happening to this angle? It's closing. So I'm going to use cosine. So it means my fx is going to be F10 cos theta, right? Then also F20 can be resolved to the x. So when you bring it down, what is happening to the angle theta? It's also closing. So it's going to be plus F20 cos theta. So I'm going to substitute their values now. F10 is 0.29. Cos theta, that is why I had to find it first. Cos theta is 0.4 by 0.5 plus F20 is 0.29. Cos theta is 0.4 by 0.5. Now if I punch this, I will need to rub this part so I can still have space. So try to take notes when you're watching the videos so that you can get the concept very clearly. Now, if I punch this value, I would have 0.29 by 0.4 by 0.5. So I have Fx is going to give me 0.464 Newton. So this is my Fx, right? Then the next thing I want to get is Fy. So Fy is simply going to be, I'll be resolving, this is my y-axis, this is negative y, and this is positive y. So anything pointing down will be pointing to negative. So if I drag this force, bring it to the y-axis, what am I doing to this angle? I'm opening the angle, because when you're dragging this down, the angle is increasing, is opening. So I'll be using what? Sine. So, and remember, when you bring this, it's pointing down, which is what? Negative. So I would have negative F10, then sine theta. Then the next thing is to resolve F20 to the vertical again. So when I drag F20 to this point, what is happening to this angle? It's opening. So I would use sine, and then it will be pointing to the positive. So it's going to be positive. So plus F20 sine theta. Now to substitute, I have negative 0.29 times sine theta. Sine theta, we found it to be 0.3 by 0.5 plus 0.29 times 0.3 by 0.5. Now looking at this, since this value and this are the same, obviously they will cancel out. So this will go, become 0. So you have that your Fy is actually 0. So we have actually gotten our forces. So seeing that this force that will act on the charge Q has only x component, it simply means that the magnitude of our force is going to be 0.464, and the direction of that force is going to be along the x-axis, simply because there is no y component. So the magnitude of our force is 0.464 Newton, and the direction is along the positive x-axis. I believe this concept is very clear to you. Do well to subscribe to my channel, like my videos, and share with your friends, and also try to watch the other video where I solved this same problem using another method so that you can balance out the concept. All right, thanks for watching. Remember, this is prime concept.